We're going to use implicit derivatives to find the equation of a tangent line. So let's given the following equation, x cubed plus y cubed equals 6xy. So let's take a quick look at that. Let's go to Desmos and see what that looks like. So if I type that in, x cubed plus y cubed equals 6xy. We see that, and we're interested in a tangent line. So there's a lot of interesting points here. And which one do I want to work with? I want to find the equation of the tangent line. At the point 4/3, 8/3. So let's see where that is on the graph. X is 4/3, y is 8/3. So it's here, so you can see it's a positive number. Can you eyeball it and guess at what it is approximately? Get a feel for it. And we want to find out what that slope is. What is the slope of the tangent? So what is the slope of the tangent? The derivative typically represents that. The slope is change in y over change in x. The slope of the tangent will be dy dx at the point 4/3, 8/3, if I can use this notation. So I need to determine what dy dx is. That's my goal. So given that equation, the first thing I need to find is I've got to find dy dx. And then once I find dy dx, I'm going to plug in 4/3 and 8/3 to be able to determine what the slope of that tangent is. And then I can use that slope together with that point to find the equation of the tangent line. So let's look at that. Our original equation is x cubed plus y cubed equals 6xy. Again, my goal is to find dy dx. I'm going to take the derivative with respect to x of the left side is going to equal the derivative with respect to x of the right side. Now, the derivative of the sum is the sum of the derivatives. You can think in your mind sort of like it distributes. So the derivative with respect to x of x cubed plus the derivative with respect to x of y cubed equals the derivative with respect to x of 6x. So there's no issue with this first piece. The derivative with respect to x of x cubed is just 3x squared. But this next one is going to require some work. The derivative with respect to x of y cubed. That's going to require a chain rule that's going to lead us to a dy dx. So let's look at it. What is the derivative with respect to x of y cubed? What are we going to get? The derivative with respect to x of y cubed is what we want here, which is the derivative with respect to x of something to the third power, which if we think about the chain rule is 3 times the something squared, the derivative of the outside function, times the derivative of the inside function by the derivative of the something. The derivative of something cubed, 3 times the something squared times the derivative of the something, but the something here is just y. The derivative with respect to x of y cubed will be 3 times y squared times the derivative with respect to x of y. So we get 3y squared times the derivative with respect to x of y is dy dx. So that's what the derivative with respect to x of y cubed is. It's 3y squared dy dx. equals. Now the next piece is the derivative with respect to x of 6xy. To do that, we're going to need to use the product rule. So how are we going to do that? Well, derivative with respect to x of 6xy is what we're working on here. Using the product rule, I'm going to say that u is 6x and v is y. U prime is the derivative with respect to x of 6x. V prime is the derivative with respect to x of y. U prime, derivative with respect to x of 6x is 6. The derivative with respect to x of y is dy dx, almost by definition. And then we know our product rule. uv prime is u prime v plus uv prime. So knowing that, then what can we say? The derivative with respect to x of 6xy is u prime v 6y plus uv prime plus 6x dy dx. And that's what I will plug in for the derivative with respect to x of 6xy. So we have this piece now, 6y plus 6x dy dx. And remember, our goal is to find the slope of the tangent. So our goal is to find dy dx. We write it without parentheses because they're just kind of getting in the way here. 3x squared plus 3y squared dy dx equals 6y plus 6x dy dx. Let's get all of the dy dx's on one side. So I think I will subtract 3y squared dy dx from both sides. And get everything else on the left, so I'll subtract 6y from both sides. And then we see what subtracts out. And where are we? 3x squared minus 6y equals 6x dy dx minus 3y squared dy dx. Remember, my goal is to solve for dy dx so I can factor out that dy dx on the right side. Factoring out the dy dx, we get 6x minus 3y squared equals 3x squared minus 6y. Now to solve for dy dx, I will divide both sides by what is multiplying dy dx. So that will give me 3x squared minus 6y divided by 6x minus 3y squared equals dy dx. And let's just clean this up ever so slightly by recognizing I can divide out a 3. If I divide a 3 out on top, 3 times x squared minus 2y, just to check, 3x squared, check, 3 times 2, 6y, check. On the bottom, divide out the 3, and I get 2x. 3 times 2x is 6x minus 1 times y squared. 3 times y squared is 3y squared equals dy dx. So you'll notice the 3's divide out, and we get dy dx equals that. Dy dx equals x squared minus 2y over 2x minus y squared. Now, what was I trying to do? What was my goal? I wanted to find the equation of the tangent line at a certain point. The equation of the tangent line at 4/3, 8/3 is what I wanted to locate. So the slope of the tangent is going to be dy dx evaluated at that point 4/3, 8/3. So I've got to plug 4/3 in for x and 8/3 in for y, which is certainly going to be unpleasant to do. 4/3 squared minus 2 times 8/3. Downstairs I have 2 times x. So what is that? 2 times 4/3 minus 8/3 squared. But I'm going to use a calculator to help me with this, just to kind of make my life a little simpler. So we pull up the calculator. I am going to let 4/3 be x. So 4/3 store in x. And 8/3 store in y. And I've got to plug it into what I had, which is x squared minus 2y over 2x minus y squared. So I'll plug that into my calculator there. So upstairs, x squared minus 2y, x squared minus 2y. Divided by downstairs, I have 2x minus y squared. And the result is 8/10, also known as 4/5. So we believe the slope of our tangent is 4/5. So what does that tell me? Remember, the point is 4/3, 8/3. So we'll write that down. Point is 4/3, 8/3. And we believe that the slope, m, is 4/5. If I want to find the equation of the tangent line, I'm going to use point slope form. Y minus y1 equals m times x minus x1. Y minus 8/3 equals m equals 4/5 times x minus x1 times x minus 4/3. Now let's go back to Desmos and see if indeed that looks like the tangent line to the graph at that point of interest. So here we are back at Desmos. There's our graph. There's our point 4/3, 8/3. Could you believe the slope of the tangent line is 4/5, 0.8? Well, let's find out. Y minus 8/3 equals m times x minus 4/3. And that looks pretty good to me. That red line looks like a fairly good approximation for the tangent. Of course, we could zoom in on it. And if we get close enough, the red line and the purple graph should be basically the same. And as we're zooming in, I think that's pretty good evidence that the red line and the purple line are basically the same. So indeed, we have successfully found the equation of the tangent line. What's our process again? We had to go ahead and find dy dx. That required a lot of analysis using implicit derivatives with functions of y and using the product rule as well. And then plugging in those values once we did it.